Alrighty, good morning everybody, and welcome to our second session today. So welcome to our in-person people who are trickling in, and to everybody on the cameras, hello. Glad you can join us virtually as well. Always nice to be able to do these things hybrid. So my name is Pippa Hillebrand. I am a software development engineer within the EC2 core platform in AWS. And today I'm going to talk a little bit about what I do. I'm going to be sharing some of the stuff that we do internally inside of EC2 and AWS to kind of remove some of the boring shared aspects of engineering and allow development teams to really focus on the stuff that matters to them. So, agenda. I have broken my talk up into 3 main sections. I'm going to start with some definitions because I have found that terms that I use every day are not necessarily terms which are well understood, and so I'm going to give some definitions. Then I'm going to talk through some of the motivations around why would you want to do some centralization, why would you want to, share the workload in this particular way. Then I'll dive into some of the strategies that we have used to do this sort of a migration, and some of the lessons that we've learned, the sharp edges that we've found, so that if you decide to do the same thing, you don't run into the same issues that we did. So, definitions. I'm going to start with platform engineering. Now, this is, you can argue if it's really a job title. Platform engineering is something that a lot of us do without realizing it. And it's actually what makes up the EC2 core platform. But we still consider ourselves software engineers. Basically, platform engineering is focusing on infrastructure as code kind of systems and that sort of thing. It used to be called site reliability engineering and kind of went sideways. That's basically what it is. For most of us, we're just software engineers and our specialty is platforms. Then undifferentiated heavy lifting is a term which we throw around all the time within AWS. And it's all that stuff where you go, every single team has to do the same thing every single time, and you kind of get over it. And instead, it's, so it's undifferentiated. There's nothing special about it. As an example of this, EC2 as a product pulls away all the undifferentiated heavy lifting of data center management. We manage availability zones and regions on your behalf. We give you an interface, be it an API or the web UI, and from there you can get your servers without having to specialize in data center management and being DCOs and all of those great things. Then a bottleneck. This is, we all know about bottlenecks in traffic. It's basically anything that gets in the way of releasing features. It can be bureaucratic processes because you need to get your thing reviewed by this team and that person, or it can be a fragile shared code base where if you want to have 10 engineers all touch this code, it's just going to fall apart. That's going to be a bottleneck because you need to be careful that you're not rolling back somebody else's code, and it's just chaos, and we tend to prefer to avoid that. Then observability. This is just very broadly anything that allows you to see the state of your system. So metrics, logs, alarms, dashboards, all of these good things, and then sharing that across microservices or macro services or monolithic services. Hopefully you don't have too many of those. And my final term here is orchestration, which is a nice big one. Which basically is routing between microservices. So if you're thinking you want a nice public product name to go with that Kubernetes control plane, does orchestration. It basically says, okay, I start here, I go there, I do that. And that's orchestration. So we've got some terms. I can now use them. Great. So I'm pretty sure most people have had these like coffee machine, water cooler conversations about that one thing that you just all have to do, and it's really annoying and you wish you didn't have to all do it. That's the sort of stuff that we're trying to avoid having. There's some stuff that's everybody's annoyed by, that everybody has to do, like root cause analyses, but those are very, very specific to your business unit. You can't really outsource those to a central team, although it would be an interesting experiment. But there's some stuff that you really can. So I already mentioned that EC2 does this for data centers for our customers. So we take away the data centers, we give you rented space on our servers. But now, what's next? Maybe you don't want to have to manage all of that, those instances. You've got too many instances. You don't really want to have to think about them. So you can go a step further. You can use containers. You can use one of our managed container services, so Amazon ECS or EKS. And you can put auto-scaling there. But not everybody wants to use containers. And for some very good reasons that are a talk all on their own, that I'm not going to go into, EC2 kind of struggles to run on some of the layers of AWS. So we've built a system that means that customers or service teams can put together just a configuration of this is what I want from my instances. And you put it together and you say, okay, here's my config, now you go manage it for me. And that means that I don't have to worry about instance restarts anymore because somebody else is worrying about that on my behalf. And I don't have to worry, this is a pretty common one, about operating system updates, that sort of thing. They come in all the time and everybody has to do them. But now we have a central team who's able to work through those, and not everybody has to do it. It's a problem that's centralized, and they're taking that off me. And so this also gives us some really great opportunities to resolve underlying issues on other people's behalf. So I mentioned the OS patching. It's also, there's so many different little updates that we do on a different team's behalf. And then I put on there interesting problems to solve at scale. Nobody really wants to solve the problem of having to do their updates in every single team. It's a waste of time. But when you're trying to solve that problem at the scale of EC2, and we've got 20-something regions, which, every single one of them needs to have an operating system update across every server, that's a whole nother problem. And that becomes an interesting software problem to solve. Then I spoke a little bit about bottlenecks. Now, you think about EC2 APIs. We have 500 and something API operations just in EC2. But there's one endpoint. If you're going to do something with EC2, you still go to ec2.amazonaws.com. And that means that at the very least, there is a routing server that knows about every single one of those operations and knows where it needs to go. Now imagine for a moment that there's business logic in that routing server, and you want to launch a new operation, but so does everybody else. It gets a little bit hairy, and you kind of go, yeah, okay, cool, you can launch your new feature in 6 months or a year if you're lucky. But we kind of want to be able to avoid that. And so by building an orchestration platform behind that for service teams to actually just, all the routing platform does is it says, okay, what's your configuration? Great, let me go set that off. Becomes super fast comparatively, because now you're not waiting on this one shared code base that that team that you didn't even know existed pushed a bug, and now they have to roll it back, and now your feature is gone as well. Instead, we get this nice pretty graph that you've got there of AWS features where that's not building on each other, that is just independently each year. And so we're able to pull some of that chaos out and really let teams focus on delivering features for their customers, which is what our customers want. You don't want to wait 6 months for us to give you that new feature that you've been asking for. You want it now, quite reasonably. Yeah, and it also gives us an opportunity now to integrate that orchestration platform with some of the other pieces that we build with that fleet management system. So if you've got fleet management and orchestration, you're really just focusing on your code. One of the other things that it can give us is broader observability, by which I mean across microservices and across different service teams. So if you've had the opportunity to play with building state machines in AWS step functions with AWS Lambda, you also come across the service AWS X-Ray, which takes a single incoming request and traces it through the entire process and builds you this little map of what your request does, where it hit, and that sort of thing. And you can build up systems like that with that request tracing, which we then use to say in an event, because it's also indexing failures and exceptions, you go and say, okay, which microservice actually failed in this event? And it's very easy to go and use that shared logging and that sort of thing to be able to just build up this really great picture of everything that has happened. And on top of that, if we've got a shared orchestration platform, we've got a shared fleet management platform, there's a bunch of really awesome data coming in there and a bunch of stuff that's common across every operation. So things like an operation can succeed or fail. It can have high latency or low latency. And that's the sort of thing that we want to monitor and have alarms on and best practices around. And if we've got all of that data centralized, we can also start providing those monitoring best practices without anybody having to do any extra work. So it's one of the value propositions for us is come use our orchestration platform, use our fleet management service, and on top of that, we'll add in all of this monitoring, so you don't have to try and remember, okay, which were the standard monitors that I needed to do. You just monitor your key business metrics, and you do the ones that are very specific to your team. And now, what this gives us as well, and this is what I was saying about its interesting problems to solve at scale, is we're able to build up some subject matter expertise in all of these places. Which is, it sometimes goes against this idea of, oh, everybody should be a full stack developer, you should do DevOps, you should be agile, all of that stuff. We still are. We're just specialists in within your team, you're a generalist, but then your team are a team of specialists. And this allows us to do some, rather than have every team figure out where should you put your CPU utilization monitor? What's a good time to know that your CPU is starting to get too hot and you need to scale up? We can do that on teams' behalf. We can put those in place. We can set those best practices. Our subject matter experts can go and deep dive, oh, we're seeing a lot of failures of this particular type, and figure it out and fix it. And so a great example of where we do this and where we're used to it in our industry is with networking. Networking has always been a little bit, there are these people who are experts with routers and switches and firewalls, and they tend, network engineer is a well-known term. And you can take that a step further. I keep taking things a step further. You can have subject matter experts on the networking client, which is running, your service is using to make calls to other microservices or within that orchestration platform. And you can go all out on something like this and have a look at something like AWS App Mesh, which is managed Kubernetes plus whatever containers you want to bring, and then they add in a proxy for routing, which is going like host routing, and it's intelligent routing. And then you can add to that with that proxy, because it's reading each request, it can say, oh, that server keeps failing. Like, everything else is fine, but that one server keeps failing requests. No idea what's going on, but I'm not sending any more traffic to it. Which gives you a little bit more resilience against gray failures and partial failures in your system, because you've got that subject matter expertise, somebody who can actually go and say, yes, we can look at these common failure types and root cause them and protect you from them, and you can go and focus on writing awesome features. And then this is, I've been talking about all these different systems. When they integrate together, the return on investment can be kind of astounding, because you can start giving people these things for free. Nobody has to go and do all that extra work. And so this is the automatic observability of the fleet level metrics, right? This is the thing of, oh, you're using our fleet management system? Fantastic, you've got CPU alarms, you've got thread usage alarms, you've got memory usage alarms. All you had to do was tell us where to tell you about something going wrong, which we needed to know that because we're running your servers already. And we use that same information to put those alarms in place. I talked about the unspecific aspects, updates. We've got this fleet management system. It can just recycle your entire fleet in the period of whatever you want to make it. And that means that you can ensure that you never have a server with an uptime of more than a year. We used to have these servers running for 5 or 10 years, and you're like, I don't know what will happen if I reboot it. But if you've got this fleet management system, they can tie into all of your deployment safety mechanisms and say, yep, okay, cool. Here's the deployment way to deploy safely. I'm just going to use that to also recycle all of your servers. And one of the things with these teams, which I absolutely love, is seeing their win emails come out internally, because they'll put in these things where they measure their success in number of developer hours saved. And so you'll see something where they'll say, we applied this change to every server in EC2 and beyond EC2, and it took us about 2 weeks, and that saved multiple years of developer time, because if you'd multiplied that out across every team having to do their own work, it would have just been immense cost. So, hopefully I have sold you on some of the centralization can be a good thing, that platform engineering is not evil. How do we go about doing it? And the first thing I'm going to talk about is true for any form of migration, anything where you want to change the way your service works. Testing, testing, and more testing. Because, we like to test things. The first one is that I'm going to talk about now is canary testing. Now, this is a term that software engineers have borrowed from mining, where miners used to take a canary down the shaft with them. If the canary fell over, it meant the toxic gases were getting too intense and they all needed to evacuate. Usually, at the end, the canary was fine. No cruelty to birds here. And in software, we don't actually have a little chirping bird, but we have a system which is sending traffic at a regular basis to our services and just kind of providing us with a heartbeat metric. This is a little bit more complex than just your ping, right? You want more than just the server is responding on this port, because it can be listening on the port and responding to a ping and also failing every single request that you send to it. So your canary needs to be exercising your business logic and providing you with this, yep, I can actually get a 200, I can actually get a 200 every minute or more, depending on how you want to do it. And this can serve as a really great proxy for customer metrics, because if you're doing a big migration, we have a tendency to try and do it when our customers are not using our service. But that also means that they don't tell us that it's not working anymore, because they don't know. And so the canary is there to just say, yep, still working. You changed everything under the hood, but still working. Then regression tests. I think most developers have heard of them. Most developers have probably even written them. But if you're going to do a big migration, you want a really comprehensive suite of regression tests. And these are not bug fix tests. These are not, I want to go and fix this bug. You might do that when you're writing a regression test suite, but that's not the purpose. The purpose is for the old code to be passing 100% of the time, and that when you migrate to the new code, that should also be passing 100% of the time, down to the text in your exception messages, if you're feeling so pedantic, because I've never parsed an exception message. I definitely have, and I know our customers do it as well. People parse the text in your exception message and rely on it. So if you want to make sure you don't change your behavior, it goes that deep. Then, we're getting into the more common kinds of testing, but again, for a migration, stress testing and load testing, super important, because hopefully you're optimizing with your migration, but it is so easy to do the opposite. And then at load, you're like, oh no, but I should be fine. I was fine on the old system. And you get one of those spikes, and your servers all fall down because they're using 50% more CPU than they used to be. And you go, but why, what? If you've got good load testing, you can say, okay, this is the load I can run on the old code, this is the load I can run on the new code, and you can make sure that it all works. And then, every other testing strategy that you can think of still applies. So testing's all very well and good, but it's not really the be-all and end-all of a migration of this kind. When you want somebody to change from doing things this way to doing things that way, none of them wants to work on a meh migration instead of their shiny new feature. So you have to convince people that this isn't going to impact their roadmap, they're still going to be able to do the good stuff, which kind of comes in two forms. The one is to be able to onboard or opt in easily. And so I'm going to go back to our fleet management system and give you a little bit of a walkthrough of what it takes to onboard to that. So I have this pipeline of a service which deploys to every single AWS region, takes a while to get to all of them, has a whole bunch of servers behind it. I want to put it onto fleet management. I go to their site, I say, I'm using the common deployment tooling, here it is. They run some code, they read what I've got configured, write the configuration for me, run some checks. Oh, you're failing these best practices? Real time, I say, oh, okay, I can go put those in nice and quick, fix my best practices, it's usually around alarming, put those in place, rerun that test. It says, okay, cool, you're good to go, done, there you go, we'll manage this from here on out. It's an afternoon, and that's only if I didn't have some of my best practices in place. That's easy onboarding. That's the level of onboarding that means that somebody says, oh, yeah, sure, you're giving me all of these benefits and I need to spend an afternoon maybe. Okay, I'll do it. Then the other side of this is to make opting out seem like a really, really bad idea. Now this is, I'm going to go back to our bottlenecks and our EC2 routing service where you can say, okay, you can go learn this new system of orchestration for your feature and build your new feature using this new system, and there's a bit of a learning curve and it's a bit of a new thing, but you can launch on your schedule. Or you can wait for time in the legacy system, and well, the launch schedule is you're waiting 6 to 12 months. Think, okay, launch on my schedule or wait for somebody else to have time. It becomes, it's worth the learning curve, it's worth figuring out the new system, because the alternative is not fun. Then, this is one that's a little bit of a lesson learned as well as a strategy, because when you start giving people the power to build their systems themselves, and you say, oh yeah, sure, you can launch that new feature on your timeline, that power comes with a responsibility that they didn't have before, which is to meet a standard. And in AWS, we try really hard to maintain a consistent naming standard for our operations and parameters. I say try really hard because it's not always perfect. But that's not free. And so we kind of have to have that shared standard of consistent naming. And the centralized tool kind of needs to be the thing that enforces those standards. And so with our orchestration tool, what we can do is we can actually give teams who are using it a build time failure if they're not meeting the standards. And it's the same as that fleet automation system saying, hey, your fleet's not up to standard. You don't have these safety monitors in place. And we can enforce that centrally, which both ensures that things actually work and gives us a much better customer experience at the end of the day. But with your standards, this is why it's a lesson learned as well, is you need to be quite careful. Your standards need to be easily understood, they need to be well documented, and they need to be well socialized. I can come up with a set of standards that I think are fantastic, but the best way to get good standards is to go and find a group of wildly different developers who are all going to be using my tool and say, hey, can you read through these? Can we chat about them? Because then you go find your colleague who has a completely different background to you, and they say, that is a terrible slur. You can't use that word. And you go, okay, well, let me rethink this. Let me make sure that my standards are actually appropriate. And then, so you socialize them well, you put them all together, and, all the research says diversity builds better products. It builds better everything when we have those diverse opinions. And the other reason why your standards need to be easy to use, and again, this is why it's a lesson learned, is you can have this fantastic onboarding system which makes it really easy to use, but the standards that you're enforcing are so strict that nobody can actually keep up with them, and so your onboarding process might as well have not been easy. So it's a little bit of a balance there. So, I mentioned this, that we've learned some lessons whilst we've been building these systems. And some of these have shaped how we do our future work, and some of these are lessons that we're still learning or processes that we're still working with. And so one of these is the idea of, do you chase depth or breadth in your service first? Your most complex use cases or the most possible use cases? And the answer is kind of both. Again, it's a balance. that really complex use case that you want to support. Like, let's take run instances. There's a lot of stuff that happens when you run an EC2 instance. You get a server, and then we make sure that it's in the right VPC, it has the right security groups, it has an EBS volume attached. All of these pieces have to happen. And each one of these can also be managed independently. So it can be a fairly complex system. That gives you, if you take a system like that, you can say, okay, this gives me a really nice feature list. And when I've got every feature like that, then I know I have a really deep service to offer. But there comes a point where you can look at your simpler use cases and say, oh, they needed a subset of these features, and I've already got that subset. And you start pulling those customers into your service. And the more customers you have, the more feedback you get from them, the better you can make your service. You start building up an experience. You say, oh, we have a problem like scaling. It's not going to work in that way. We didn't anticipate that until we had real traffic. Or they show the bugs because customers use our services in ways we never anticipated. And they find all the edge cases. Like, it doesn't matter how hard you test it, customers will find an edge case you didn't think about. And so you kind of balance it there. After you've kind of ironed out those first few issues, you go deep again, and you keep building that feature set for your most complex use case. Because again, as soon as you've got them on board, you really start feeling like you can do things there. But I do want to say, you need to feel like you have the flexibility to say, we're going broad, we're onboarding new people, and then you get to a point where you see that scaling cliff, and you say, okay, we're putting on the brakes. We're not taking more customers of this kind until we've solved these problems. That's one of the things my team is currently doing, is we've been broadening our horizons and getting new customers to come and use our service. And then we were like, oh, we need to fix some stuff. So that's what we're doing. And we will get more customers again once we fix these things. And you just kind of iterate as you go through. And so, yeah, it's agile within that system. We get better as we get more feedback from our customers. Then, this is one that we learn painfully. Usually when things go really wrong is, okay, I automated this fleet management system. Fantastic. I don't have to worry about my EC2 instances anymore. Somebody else is doing that for me. But then you have a bug which only shows when you get a new instance. So you say, please stop recycling my instances and managing them for me until I patch my bug. And so you turn it off. And then EC2 comes through with this rack that's running half your instances is unhealthy. We've got an actual hardware problem. We need you to move your instances across. And normally, the automation does this. Do your engineers know how to handle the case when the automation stops working? We discovered that we had some new people on the team who had never seen that there was a way to do this without the management tool. And that's the sort of lesson that comes with unfortunate customer impact. And one of the other things is that automation does not cover all the edge cases. It covers the common cases, but there is still room for a DevOps kind of style of working. You're not, you don't need to say there is no room for operators. Your operators are hopefully streamlined to focus on business logic and on the stuff that differentiates your product without having to focus so much on the common areas. But they still need to know how to operate. They still need to know what to do in an outage. They still need to have really good, well-written run books. And there's a certain extent to which the onus is on us as the centralized service teams to write those run books, because it's our service, or lack thereof, which is causing these operators to need to do something that actually requires them to follow a run book. And so some of these things are kind of important lessons. So I am getting to the end. In brief, I talked about some various things that I think are important definition-wise. Platform engineering is fun. Observability is important. Orchestration is what I do, so I had to include it. And undifferentiated heavy lifting is what we do as a company. Then some of our motivations, return on investment is always fun. Making people's lives easier, and particularly when you can actually see it working, is fantastic. Some of the strategies that worked for us, and some of the places where we know we could do a little bit better, and some of the lessons that we've learned. So thank you very much for all of your time. I'm not going to be taking questions now. If you want to learn more about any of this stuff, if you're interested in any of it, there's no way we're done building all this stuff. Come find us at the stand, reach out to us on Slack. We kind of have two channels that you can reach out on. There's the talk channel, the track channel, so I'm in there. But we've also got a sponsor channel. So I'll plug our sponsor channel for the virtual people. If you want to reach out there, please feel free to do so. And then there is a survey. I'm told it was mentioned in the keynote, and that you can technically win a robot vacuum cleaner. So fill it out at the end of the day. Make sure you stand your chance to win a vacuum cleaner. So yes, thank you everybody.